Hello everyone, I am Anurag Verma, a class 12 student at Mahaveer Public School, Jaipur. Over the past 4 months, I have been working on an AI project that combines historical data analysis with machine learning prediction. I am here to tell you about how we can use the Titanic disaster, one of the history's greatest tragedies, to teach people about artificial intelligence and data-driven decision making. This project is my solo venture, but I have been guided by my AI teacher, Ms. Suman Taneja ma'am, and supported by my parents and my sister. Together, we have created something that transforms complex algorithms into an interactive and understandable tool. Choosing this project matters for three reasons. First, educational value. Students need head-on experience with real machine learning, not just theory. My tool makes k-nearest neighbors algorithm transparent. You see exactly which historical passenger influenced the prediction. Second, community impact. Data literacy is essential today. Understanding how AI makes decisions about people is crucial for informed citizens. Third, AI ethics. I've used publicly available historical data responsibly and ensure the tool shows its reason, no black box predictions. Here's our solution, an interactive KNN classifier built entirely in Microsoft Excel and Orange data mining tool.
This is an interactive prediction tool that I have built in Microsoft Excel that uses KNN to estimate whether a Titanic passenger would have survived or not based on real historical data. As you can see, I took real 100 passengers data. This includes the passenger's age, gender, class, the port of embarkation, whether they were traveling alone or not, and their survival rate. Now in test sheet we have our Titanic survival prediction tool. In the input data area, we have to add the features of the test passengers. Let's say age of the test passenger be 54, gender be male, passenger class be 2, embark port C, was traveling alone, yes. Now in the data processing area, the features are normalized. Age 54, gender male to 0, passenger class 2 to 2, embark port C to 0, traveling alone 1 for yes. Now it calculates the Euclidean distance of the test passenger from all the 100 passengers. In the back end, it calculates the top 5 closest passengers according to their distances. The passenger IDs are shown. Finally, in the results section, from those 5 most similar passengers, the tool checks how many survived and how many did not. Using majority voting, it then generates the final prediction, survived or did not survive. Like here, the passenger will not survive. I also built the same KNN model in Orange data mining using the same Titanic dataset and features. Here, the file loads the same 100 passenger dataset. Select column picks age, gender, class, port, alone as features and survived as target. KNN widget uses k equal to 5 Euclidean distance exactly matching my Excel formulas. Prediction widget shows individual results matching my Excel test cases. Now here we can see the graphical representation of the outcome data. First, in the scatter plot, we can see the fair distribution. Second, in bar plot, we can see the survived cluster versus the did not survive cluster, marked as red and as blue respectively. Third, in distributions, similarly we can see the red for survive cluster and blue for did not survive cluster. These three graphs validate my Excel KNN model is correct and reveals Titanic survival patterns clearly.
Why I am the right person to deliver this solution. I completed IIT Madras 8-week AI certification course mastering KNN, K-means clustering, supervised learning, and model evaluation. I validated my Excel KNN results using Orange data mining, an industry standard tool, and achieved 100% consistency. My tool delivers transparency, seeing which historical examples influenced the decision. I use public Titanic data responsibly, documented my process completely, and ensured the model shows its reasoning at every step. I spent 60 plus hours across 4 months, from July to November 2025, researching, building formulas, testing, and documenting every decision. We can predict other real world scenarios also: loan approvals, medical outcomes, college admissions, etc. Teaching AI ethics through hand on examples. Machine learning doesn't have to be a black box. With the right tools and teaching, anyone can understand how AI thinks. That's what I am passionate about delivering. Thank you.